Hello,
Yeah,
how are you?
yeah, fine.
My screen is visible to you?
Yeah, sir. Now it's sharing.
Okay. So right now I have the solution for you. That one waveform, digital waveform solution.
Yes,
So
a digital waveform. Yes.
yes, I just uninstall my LabVIEW. Right now, as you see, it is LabVIEW 2023
23 is the latest
version
one.
is there. Okay,
Mm-hmm.
so you just need to run your setup once again because it for the digital waveform it require only the basic lab view.
Oh,
You need
okay, sir.
not to select anything else. It
Mm-hmm.
just like I show you in right now I have three versions. LabVIEW 2023, I show you once a minute. Over here this is my LabVIEW 2023 version. LabVIEW 2019 version I have. LabVIEW 2021 version I have.
Okay, sir.
Because the different hardware setups require different versions. As you see
Okay.
over here, I show you today that my Rio, that is a educational board. I show you the picture. After that, I show you the hardware. Basically, this is a FPGA board provided by the National Instruments. Is visible to you?
Yes, visible.
Okay. So over here, this is the NI Myrio.
Okay,
It is
sir.
the advanced version of the deck card. It is Xilinx supported. Okay. So it has inbuilt functions like it has accelerometer also. You can build different projects using this. You can make a drone also using this project. It has audio acquisition and audio generation capabilities and the counter and the mm, signal acquisition speed is more as compared to the previous one that I have NI 6001. Okay, so today I just show you, and in the future lectures we just go with this also. So for this version, if you want to work with this, you need previous version LabVIEW 2019 or LabVIEW 2021. Using these two, you can go through this hardware. Uh, Other than this, we have in my college NI Elvis board. This is NI Elvis. I just show you another hardware also to you. So basically, this is the Elvis board.
Okay, sir.
Okay, so over here, as you see, this is the add-on card. This is the breadboard type card. You just see over here. The base
Yes.
version is this whiteboard is the Elvis board. It is called Elvis board. You
Okay,
can
sir.
add on different boards. There is a DC motor board. There is a pendulum also available. Different NI products add-on cards are available in the market. You can go through these, but if you just have this NI Elvis board, the complete electronics and communication branch you can replace with this board only in your labs. Like it
Okay, sir.
has function generator within this. It has CRO capabilities. It has DSO capabilities. You can generate, and the number of pins over here in this board are more than any other hardware that is available by NI. Number of digital
Okay.
pins and analog pins in this case. Okay. So I just go to the LabVIEW. So you just need to I just show you the different versions also. Right now in all the versions I have waveform palette. I just select the LabVIEW. When you just go through the software installation, just select LabVIEW. Need not to select any other component. In all the functions, all the setups, you just check. Like in this case, I just show you over here waveform. I have digital waveform, analog waveform palette in 2023 version. I just show you the 2021 version. You just run your setup. You just have you just install the LabVIEW by NI package manager, or you just have the any software.
No, it's a cracked version, sir. I think it's a 2020.
It is a 2020 cracked version. It is a
Yes.
maybe 40 GB or 36 GB.
Yes, sir, maybe.
Okay, you just need to run this again, once again. Just select LabVIEW. Okay, and I just also explain you how to go through this. As you see right now, this is the LabVIEW 2021 version,
Okay, sir.
and in this case also I have waveform palette. It is taking some time. Over here, this is my LabVIEW 23 version. This is my 2020. Over here, as you see, in the 2021 version is also there waveform graph, and I
Yes.
also go through the LabVIEW 2019 version. I just download this software through the online portal
Okay, so
of
it's a
NI.
trial version or a licensed one?
It is a license. Basically, I have the crack, and you also have the crack. You just
Yes.
download the latest version. It may take
Okay, sir.
around 5 to 6 hours if your
Oh,
speed
yes,
is
sir.
as you see right now, this is my 19 version, and over here in the waveform, as you see, digital waveform is available in all the versions.
Yes.
Okay.
2019.
So right now I just remove this one. I just go through the 2023 version. So if you just I just show you how to install once again. Over here, this is the software I just downloaded from NI LabVIEW 2023 version. You just need to download 32-bit, not 62, 64. Yes, because all the modules that are developed by NI, these are compatible with 32-bit mostly.
Okay.
Okay, so I just over here, you just extract it, install. This is the simple way. In this, it is gathering information first. It is started using NI package manager also. You just download the NI package manager, or you just download through offline. It is up to you. Right now I am installing it through offline mode. As you see,
Okay.
I just selected this one, LabVIEW 32-bit. Okay, all other equipments, like in my case I just select vision development, you just skip it. Okay, and this PXI, you just skip it. You just require NI DAC Max, NI 488.2, NI Visa, we just require, then click next. Just
Okay.
you just go through this. Okay, using this setup you just get the digital waveform palette in your PC. When you
Okay.
just go to next, over here there are some additional packages also. According to your need, you can just select.
Okay.
So there are some dependencies. It will searching. As you see, you just select it or deselect it. It is up to you.
Okay.
Then next, after this, it will ask you to go through the license agreement. Just yes it and next it will start. You just download the latest version also. I'm just closing it. So today I just show you the another case of event structure.
Okay.
So I just have the VI for that version. Right now I'm just creating a Google form. Do you familiar with Google form? Google form?
Yes, a Google form.
Okay, that is part of our Gmail. We just create a Google form to take the data from our colleagues. So over here, I just create a Google form using LabVIEW with the help of write file and with the event structure. I just show you the code over here. As you see over here, once I just minimize this. So over here, this is the Google form. In this Google form, I just require the name, the roll number, the sex, email ID, contact number, and last over here I have the submit button, and over here this is my stop button. So I just first explain you the code. As you see, this is my while loop, outer loop, so it will continuously run my Google Doc. Basically this Google form continuously run until I just stop from here. Okay, so and over here this button will submit the data. When you just submit, click on this button, it will submit all these details to the file, and the file location is over here. Right now I just use this write delimited file. Over here in the file system, you just check over here, this is the write delimited file, and over here this is the read delimited file. You can use both of these in your program. Right now I am just using write because I need data from the users. So over here this is the write delimited file, and I just need to connect this file, this write delimited file, to a CSV file, comma separated files. So in this folder, as you see over here, this is my Google Doc.
Okay.
I just show you the data inside it previously. Over here, this is the data inserted previously. So name, email ID, contact number. Over here, this is the experience, but I just connect the different file with this. You can create your own file. Right now I just create another CSV file. Let's say this is a Excel file. Basically you just convert it to CSV file, save it as a, yes, you just save it as a CSV file. So initially I just make the initials. So in my Google form, the first is my name. Just close this. So first is my name, second initial is roll number, third is sex, fourth is email ID, and fifth one is contact number. Okay, so these 5 initials I required from any users. So right now I just save it, save as in the same folder as you see over here. Make it CSV, comma delimited files. Save it, because in the case of this write delimited file, it cannot read the data from Excel directly.
Okay.
So I just save it. Now I just create indicator control over here. Right now I just change this path. So for the path, you just go to the browse for path, go to the folder, and the folder is inside wherever you want. Just so in this case you just need to connect the CSV file, save it as you see over here, and in this case over here this is my event structure. Okay, so over here I just make cases. So it is the case of state machine also. Hello.
Okay.
It is the case
Yes,
of
yes.
state machine also, because in this case I just use case structure, I just use for loop, I just use with a event structure also. So how I use this, you just check. In the K event structure, I just use a button. That button is over here. This is my submit button. Okay, and this button, you just check where is it is. Over here in the 5th part, this button is placed inside the case structure. Okay, so the working of this case structure is like this. Over here I have total 7 cases. Total 7 cases.
7.
Yes, initially this is the default. It will take name as a string, this one. In the second one, roll number. In the second iteration, it takes the roll number, then sex, then email ID, then it is gone for contact number, and at last 5th, it just check the button position. It is pressed or not. Okay, until it is on the sleep mode, because event structure is there. And after that, in the 6th position, I have a dialog box, one button dialog box. It will show me the data is successfully submitted. So right now I just show you run. Right now it is in running mode. So first I just put my name, then roll number. Over here I just put sex, then mail ID. After this, contact number. So right now when I just click on this submit button, a dialog box pop up as you see. Okay, so now the data stored in the write delimited file. Just press OK. If you just go with the another data, just change the name. Let's say another data is this one. You can put any type of data, or you can just make it numeric type or integer type or string type. It is up to you. So again I'm just submit data. Okay, when I just click over here, and till now my program is running, as you see.
Yes.
So when I just put on stop button, it will stop my button. And over here, as you see, there are two cases only. One is for submit button, that is OK button. I just change the OK button with submit name, and another one is my stop button, that is this one. So my event structure will check for these two button only. Okay, and you just check the data also over here in the CSV file. When I run open this, in this case only two datas are there, as you see. These are my
Yes.
two data. Using this you can create your Google form also with the help of NI LabVIEW. So if you have any question, I just share this VI to you also. You just try
Yes.
your own and create this Google form. Any question related to this?
Yes, I want to know in the front panel. It is the name, roll number, sex, email ID, contact news. It's coming very clear, sir. How is it possible if the one by one is coming?
How it is possible means?
Because you for means if we are creating the string data,
Yes,
it's showing some different location, and then roll number we are creating some different location. But in the table, it should be coming clear one.
over here.
One by yes, sir, it's coming one by one, right? Sir? Name, roll number, sex, everything, and then it's same come like the one set of box, correct?
Yes, you create
Yeah.
your own set of box. I just show you.
Yes, sir.
Over here,
Yeah.
there is a layout. This
Oh,
is the
layout.
yes.
Okay.
This is the tab control. I just create a
Okay, sir.
tab over here.
Okay, sir.
As you see, I just put over here in the VI also. As you see, this is the tab control. This is another tab. I just right now I create. So you just remove this page. It is up to you. Right now this is the basic detail.
Okay, sir.
In this case, this VI we just created for the that company project. In that case, we just first we have targeting the data, like we just create a project for the website. Over the website, the students or the participants just put their data. Right now I just put the basic detail. In the next tab, let's say over here in the first tab, they will give their basics details. Okay, in the next tab,
Okay, sir.
after filling the basic detail, they pop up to the next page over here, like educational qualifications. In the next page, their experience. It is just like this. Okay, you can pop up or you can design your own tab. Right now I just create a Google form. In this I just create basic detail, and these basic detail one by one, how these comes, like over here, this is the I just go with the numeric. I just put name over here, then I just need a numeric one over here. This is my roll number. Then it is not a integer, because in this case I need string again.
Yes.
Because
String.
over here all the data is in the form of string only. Okay, so then I just go with the roll number. Then over here, as you see, this is a combo box. It is called a combo box. As you
Yes.
see, when we just go with the government websites and another websites where we just want to fill our initial form. In this case, we have country option, we have sex option, like this. If you just want to create this one, you just go to the string. Over here, as you see, this is a combo box.
Combo box.
Yes, in the string and path, you just drag over here. If you want to add something to it, it is up to you, like go to the edit combo box. Over here, edit items. As you see over here, you just need to insert. If you have particular, if you have a company, in your company, let's say total 10 persons are there. If you want to just insert the name of these 10 persons inside this, let's say like this, it is up to you.
It's a combo box already work. Yeah.
Okay, so this is over here. Right now I just make one initial, like select one box is there. Right now these three are there. You just make add it one. I just make one insert select. Okay, and in this select I just make it default. In the go data operation, make current value default. Right now when I just go with this current combo box, initially select button is there always, so I just put it over here. Right now like this, I just make this, and it will take data one by one. The condition, that condition is maintained by this for loop. Okay, because I just initially 0, because when I just run this code, initially for loop started from 0 iteration. It will check for name at 0 position. In the second position, it will go for roll number. In the third position, it will go for sex. In the fourth position, it will go for the email ID, and like this, it will store the data inside the worksheet also. If you just change the position according to that, the values are also changed, as you see. It is okay?
Yes, okay.
So main things, the name is maintained by this for loop, roll number is maintained by this for loop according to your condition. If you just randomly put these values, it will not like this. The data is inserted according, not inserted according to your conditions. So you just try this Google form first, and if any problem, you just message me. I just share this VI to you and the doc file also to you. So this is the another example of event structure, or you can say state machine. So we have some property nodes also in our LabVIEW programming. I just show you. So let's say I have a boolean button. This OK button I have, and in this case we just go to the create. Then we already gone through constant, control, indicator, local variables. Right now I just go to the property node. As you see over here, there are different properties related to this block. If you want to just move this value, this button to over here, from here, using programming you can move this. You just move this button to over here, like if you want to just create a SCADA. Do you know about SCADA?
No, sir.
Basically in SCADA we just create a imaginary view of a particular process, like tank filling, and some aeroplane is moving from left to right, some buttons are moving from left to right. In that case we just go with these property nodes. Right now I just explain you one property, like as you see over here, this is the value. It is similar to your local variable. I just create a value button, as you see over here. I just create an indicator over here, one boolean indicator I just need. So this is my boolean indicator. I just connect this boolean indicator with this one, and I just take another boolean indicator over here, and I just connect to this value. So over here, value signaling, control V, just make it you just need to convert this data over here. As you see, when you just create one property node through this property, there are different properties. As you see over here, you can create any property. Right now I just create value for this case, create indicator. Over here, let's check what happened. So when you hit on run button continuously, boolean has a latch mechanical action. You just need to change the mechanical action. As you see over here, according to our condition, right now it is true. So you can change any property through this. You can disable it also when you hit on run button. When right now I just pressing it again, it is just asking me to enable it. Okay, using this property you can enable, disable, you can move. 1 minute, I have controls also over here, size. In the next lecture I just go through all the conditions and I show you what happened with this button. Let's say height, I just show you, just make it to the all right, create indicator over here, not create indicator, control over here. I just continuously run it. So as you see, it is visible to you what happened to the button. So you can change the height, you can change the position using these properties. Like I just create another property also, I just copy it, create another control over here, and in this case I just go with the width. So as you see over here, right now I just make it 0 and run it. Now the position size of the button, as you see, and when I just make it 100, you can change the size like width, height according to this. You can move this button from left to right also. I just check size, position, it is related to the position. I just go to the left and over here I just put horizontal, just connect this one. So I run it continuously. It is visible to you?
Yes,
the position is moving, and right now I just make it 100, and right now I just run it, continuously run it. So as you see, my button moves from left to right. It is up to you how much you want the displacement in this. It is right now moving from left, and if you want to just go with the right, it is up to you, the position, or top to bottom, it is up to you. Create another control. Basically these are the property nodes related to any button. It is related to boolean button. You can create for numeric one also. Right now I just go with that numeric one. As you see, right now it is 0 position. Make it 100, 200. I am not changing the position from manually, just changing the value in the button, the position moves. Using this you can create any, like if you want to create a traffic light, so over here you have traffic light, over here you have traffic light, then you just insert a picture of a car and you want to just move that car from one place to another place, you just go with this property. Okay, you can create your program. I just show you examples also that already created by my students. The traffic light case. So these are the programming part, some basic programming you just try. Today we just go with the analog part of our DAC card, analog data acquisition and analog signal creation. So right now again I just open first Max, because I just installed a new software inside it. I just want to check the device drivers are available or not. So now I just connect my DAC card. As you see, one device is simulated initially, that its name is NI simulated DAC device. Earlier I just explained you how to simulate a device.
Yes, I already.
Do you know?
Yes, I know.
Okay, so right now I just delete this one. So over here this is my device. So today I just first connect a potentiometer with my DAC card. So for the potentiometer, you already know that. I just show you the video also. Video is visible to you?
Yes, visible.
Okay. So as you see over here, I just have the potentiometer with me.
Okay.
I just connect one end with the plus 5 volt, the extreme another end with the ground pin, and in the case of potentiometer I just go with the differential mode in this case. So
Okay.
over here create a new VI first, Control T. I just show you the express DAC assistant mode. In this case we just acquire the signal, analog signal. So first I just So in the case of analog data acquisition, so as you see over here, I have AI. AI stands for analog input. Okay,
Analog input.
analog input. You just need, when you just go with the analog input, analog voltage is there. I just select the analog voltage. As you see right now, I just select AI0.
Analog input.
AI0 I just select over here. Just finish it. It is asking me to configure the port. So over here there are different information related to the different modes. As you see over here, we have differential mode in this window. This is the differential window. Depending on your specific hardware, you can use positive and negative pins. And over here below we have the RSC mode, measurement made with respect to only ground. There are different modes. It is related to according to the hardware. Okay, right now I am just going with the differential mode. Okay, so in this case the maximum voltage, that is my 5 volt. You can make it default also, and the minimum voltage is 0. Okay, 0. So I just make it 0, and over here I just make one sample on demand. So in this window you just check the values of the potentiometer. So for that purpose, when you just go with the differential mode, you just need to ground the negative pin. Over here, as you see, there is a plus pin, there is a ground, and there is a negative pin also. You just ground this negative pin. I just connect it. 1 minute. When you just not connect your negative pin to the ground, in that case there is a variation of signal, variable signal is there. So over here these are my 3 pins that are connected to ground one, green one is my signal, and yellow one is my negative one, and over here this is my 5 volt pin that is available on board. I just connect it to the potentiometer, positive, then green one is connected to the ground, not ground, it is my signal pin, and another 2 are my ground. So as you see over here, I just made the connections for this potentiometer only. Okay, so when I just run it, continuously run it, you just check over here the values. Right now
1.61,
2, 3. Right now I am just moving the potentiometer. Right now it is maximum
5 volts, 5.0,
and right now it is minimum. It is nearly equivalent to 0. Okay, you just make these changes because it is showing negative. You just make changes in the software also. Right now I just press OK. So there is a data port available on this DAC assistant. After the configuration of this DAC assistant, you just make the condition when the value is less than 0, in that case it is equivalent to 0. In the software part you can make these changes so that your condition meet, because in this case we just make the minimum value should be 0. So as you see over here, I just got the data, and over here you can create your meter, because in this case my maximum value is 5. Just connect this one, and for the continuous reading I just create a loop over here, create control, run it, and as you see right now I just move the potentiometer,
changing 3, 4, 5.
okay. So using this you can read the signal, analog signal, any type of analog signal you can read. I just show you the another sensor also. I have with me the IR sensor. Basically in the BTech projects students use this. This is the IR sensor, infrared sensor. It basically used for data acquisition, or you can say the object detection. We can use this. Okay, so this is the module. Over here these are my IR, this is my transmitter, this is my receiver. So I just connect this sensor with this DAC card. In place of potentiometer I just connect this sensor. It requires VCC because this is a module. It requires 5 volt. So I just connect this signal. So as you see, I just connect the connections. Right now I just connect the VCC of this sensor to the 5 volt, ground to the ground, and middle one is my signal. So when I just make my hand in front of this, as you see, object is detected. Right now it is showing around 3.6 volt. I just show you the value also, how much this sensor will generate when it is just detect the signal. Digital display. So right now again I just hit on run button. So it is 3.6027. When I just remove my hand in front of this, so basically there are around 10 to 20 sensors which generate only signal when these detect the object, like this IR sensor. In the case of this IR sensor, another is PIR sensor, passive infrared sensor. Basically that sensor is used for movement. it will detect the movement. Right now, just when I just move study over here, this sensor will generate 0 value. When I just move my hand in front of this, so phase changes, it will just check the phase change in a particular range, and according to that it will generate values. Right now I just check I have that one or not. I just show you. This one is the PIR sensor.
Okay.
Passive infrared sensor. It is basically used for the to check the motion. In the case of study, it will not generate any value. But in the case of movement, like if you want to just check the persons or any for theft detection, you just want to check after when you are not in at your home, and in that case someone enter to your room. In that case, it will detect the movement of that person, and according to that it will generate signal for you. Okay, this is the passive infrared sensor. It is again, it require VCC, ground, and it will generate a signal. Right now this IR sensor is also generating signal for me, as you see over here. When I just face I just press my hand in front of this, I just make my hand in front of this IR sensor, it will generate a value. I just use this value any program. Okay, so in the next case, this is the case of signal acquisition. You can make it analog acquisition. You can use this IR sensor for digital acquisition also. It is up to you. Okay, so next is our signal generation, analog signal generation. So for the analog signal generation, I just, because right now I have multimeter, 1 minute, I just bring the multimeter. So using that multimeter, we can check what value is generated using this analog pin. So in that case, you just make the connections of analog pin. So over here, as you see, I have analog pin, analog 0 and analog 1. In this case, in this deck card case, we have only 2 pins, AO0 and AO1. And in maximum cases, like in educational cards, we have only 2 pins. In the Elvis board also, for the analog output, we have only 2 pins. In the MyRio case also, we have only 2 pins. I just show you. 1 minute, I just bring the multimeter.
Yes.
So right now, I am just going with the voltage signal. Hello.
Yes, sir.
So I just generate a voltage signal, and I just read this voltage signal to this voltmeter, multimeter. So first, I just connect AO1 I am using in this case, and 1 pin for the ground. Stop this program, delete this one. Again, just go to the express input, Right now again the same question is there. You can go through the input DAC assistant or output DAC assistant. It is the same.
Yes. Okay, sir.
So over here right now I am just generating a voltage signal. So in between I just connect this multimeter with my so as you see over here it is asking me acquire or generate. Right now generate signal, analog output voltage. There are two pins. Right now I just connect it with the AOS 1, analog output 1. I just finish it. So over here again the range is given, you with which range you want to go. Initially I just make it one sample on demand, and over here these are the values. Right now as you see these analog output port will work with only RSC mode. Okay, it is
Yes.
default condition, RSC mode is there. So I just make it. So initially right now what value you want to generate, right now I just make it 2, applied value to all. I just connect this. Right now I just make apply value to all. Over here as you see value out voltage is 2, but when you run it then it is over here. It is visible to you?
Yes, it's 2.00.
Basically it is not exact 2, it is varying.
Yes, it's no, it's a 2.0034 varying a little bit.
Yes, it is varying, but when you just make there is a difference always there, because it is up to multimeter also, and it is up to the card also, what type of resistance are there inside this. According to that, right now as you see when I just make it 3 and again I just apply it, right now it is showing or not?
3.34. Yes, it's showing 3.004.
Okay, so this is how you can generate signals, analog signals using this. Let's check for the higher value. I'm just going with the 8 volt. As you see over here it is 8 volt or 8 volt, it is exact 8 volt on the
8
value.
volt, yes.
Okay, so when you just go with the higher value, let's say I am just going with the 15, apply it, it is showing DAC assistant error, because in the electronics case we just go with -10 to +10 volt, and after this we in the case we just enter in the case of higher voltage, that is the part of electrical. In your industry maybe you are using with the same voltage or maybe up to 15 volt DC. In this case you just give knowledge me about the industry, in the electronics industry, up to what voltage you are working.
For supply side we are working maximum 14 volt, sir.
Maximum
for the
14
for the IC supplies, and for the MCU supply we are working on 3.3 volt only maximum.
Okay, okay. Basically if I just limit you just work with up to maximum 15 volt.
Yes, sir, 15 volt.
Okay, you are not working with AC.
No, AC we are working up to universal standard 85 to 230 volt.
Okay, mainly basically all the equipments work on DC only. You just convert that AC into DC, then you just make changes in the driver circuitry only.
Yes.
So this is how data acquisition happen using Express VI only. Right now I just show you the Express VI.
Yes.
Now I just show you using DAC assistant. After that we just go with the Visa.
Visa. Okay.
Okay, so right now I just show you the Express, not using the Express VI, because in the case of Express VI we have different problems when you just go with the program or go with the hardware part, because we are using the VI that is created by another person. These Express VI are created by NI only, and
Okay.
you just need to satisfy his condition or the NI developer conditions. Right now I just go with the Express VI. I just go with the DAC max. So over here in the measurement we have the DAC max. I just lock it. So there is a fixed pattern all the cases for reading and writing. You just change the reading or writing. So now I just show you how to generate a digital signal using this DAC max. So first,
Okay.
in the every case you just create a channel, virtual channel, then you have to start the task. This is the fixed pattern. You can find out in any video, any book also. So after this you just now write, because in this case I am just going with the write case, digital write. You just connect real task to real out and error into error out. After this you just need to stop the task. The starting and ending points are nearly same in every case. This clear button is up to you. If you want to clear the previous data, in that case you just need to connect this. And in the dialog box over here there is a simple error handler. You just connect this. If some error is there, it will automatically handle it. And over here, as you see, it will demand physical channel. Just Control H. There are different information related to this. You just go with this physical channel. Over here we just select the pin, because in this case I am dealing with digital signals, so you need to select the digital pin. Right now I am working with digital out, because I want to just generate. So digital out is there, and in this case also you just select the digital pin, single channel, single sample, boolean line 1. Over here I just select. So over here you just select the line, create the control button, or create constant is up to you. So when I just create constant, in this case the digital pin, when we just go with the digital pin, all the 13 pins are available over here. As you see, port 0, line 0, port 1. It is not asking me like in the case of Express VI. So I just need to select the pin. So over here this is my digital pin. So if you want to go with multiple pins, you just need to select multiple pins over here. So just press Control. So 1 minute. You just go to the browse first. It is taking. So as you see over here, you just need to select many pins. In that case, this is the DAC clad question also. You just check what happened when we have multiple pins in this case. Control, I just select these pins. It is up to you. You can select one by one also, and you can select like this also. So over here, as you see, total 7 pins are connected. I just press
Okay.
OK, and the format for this is, as you see, 0:6, 0.6.
Okay.
Okay, so using this is the case question of CLAD also. In this case, total 6 lines are available, and using digital this array function, you just separate these signals, these lines. Okay, so right now I just again browse this, and I just only select one pin in this case first. So okay, you can select from here also. So right now I just select line 0. This is the format difference, you just remember. And over here you just need to put the data. So over here I just select button, and this button goes to this data over here, and I just go with a loop for continuous data generation, create control over here. So this is my software part, and now I just go with the hardware part. In the hardware part, I just connect a LED to the digital pin. It is up to you which pin you are using. One pin is connected to the ground and one pin is connected to the pin. So I just connect a LED. So now again I hit on run button. It is running continuously. When I hit
Yes,
on push button, it will generate a signal. It is up to me. So now if you want to go with multiple signals, so in that case you just go to the browse, select multiple panes, and in that case you just need to select multiple buttons. You just select multiple buttons, like I just show you. I just copy this one like this. Over here I have 3 buttons. You just create a build array function. Build array function you just use, and in this case the output goes like this,
multiples.
and this pin goes to over here. In this case only one pin is there, so that's why it is not connecting to this. It is showing me error. Okay, so you can go with multiple pins. So this is the main format for digital writing. In the case of digital reading, you just remove this. And in this place you just go with digital read. Again you just need to select the working of this block. It is a digital or analog. It is working with single line or multiple line. It is right now digital signal, single channel, single sample, boolean line. I am working with single line. So over here I just delete this, and in this case data pin available on right side, because in the last case it is available on the left side because it's demanding data. Right now it is generating data for this software. So over here this is my data pin, and when I just connect this pin, and in this case there is one error also, because initially I just select the digital pins as a output pin. Right now I just make it digital input pin also. So now I just connect the pin 0 pin to the plus 5 volt. Let's check what happened when I just run it. As you see, it is on, and when I just remove it and connect it to the ground, it is ground. So this is how you can generate analog digital signal and acquire digital signal. In the case of analog signal, you just change over here, only over here. You want dBl value, means numeric value, or you just need a waveform, you just select. Right now I just make dBl. Over here you just need voltage. When you just select change the over here, when you just change the value over here, in that case it is showing the digital port only. In that case you just need to delete this, again create control over here or constant over here. Right now I just create constant. When I just make it analog input voltage, it is showing me only analog values, as you see. And when I just make it analog output voltage, in that case again it is showing analog input. Right now I have to again delete this, create control over here again. So this is the main points over here, and you create your own analog signal, digital signal. If you want to go with multiple signal, you just select over here, and there is a simple method also. If you just make for one pin, like over here I just make analog input, I just select this. If you want to go with multiple pins, in that case you just select this one, copy this. This is the second easy method. In this case you just need not to go with this array operations, because it is selecting individual values. Okay, so it is up to you. So this is for today. In the next lecture we just go with different software examples, like I just show you the XY graph. This is the mixed graph, this is the XY graph, this is a digital waveform graph, we already know. So we just discuss with these pins, these blocks, and in this XY graph you just generate these, let's say one data is on x-axis, one data is on y-axis. You want to plot Lizasius patterns, you just want to draw. In that case that we just study in our first year exam, BTech first year, we just create these signals in this XY graph, and we just show you, I just show you the mixed signal. Like I have a sine wave, and you want to just generate this sine wave into, you just want to convert this sine wave into digital form, means 0 1 0 1. So you create signal according to this mixed signal graph. We just go with in the next lecture, and we just go with the visa also. In the case of visa, we basically we use visa for the third party data acquisition, because in the case of NI data acquisition with the NI DAC card, you just need not to require visa. Okay, you just go with this DAC assistant that is available in this also, as you see over here, and you just go with this. But in the case of third party, you just need visa. So over here in the measurement, as you see over here, we have visa, VISA. In the same way, as you see over here, this is my general selection, this is my start task, this is my read or write, this is my stop. In the same way, we just go with the visa also. The pattern is same. You just need to drag and drop the signals, and you just clear with the type of data you just want to acquire. You just go with visa. And if you just want to connect your third party, like your oscilloscope or another radar system with your NI, because we just already created the software for Air Force Palam base, that is inside in Delhi, and we just create using this one, GPIB bus controller. We just create using this. Again the pattern is same. First start the task, then you just read or write according to the inputs. So in the next lecture we just go with the visa. Okay.
Okay, sir.
Okay.
Okay, sir.